All right, hello everyone. Section 7.4 is going to be on trigonometric identities. So we only have two objectives in this section. One, we want to use algebra to simplify trigonometric expressions, and two, we just want to establish identities. So this section will establish identities that involve trigonometric functions. First, let's just identify what identity is. So in our definition, identically equal identity and conditional equation, two functions f and g are identically equal if f of x is equal to g of x for every value of x for which both functions are defined. Such an equation is referred to as an identity. An equation that is not an identity is called a conditional equation. So the following are identities, things like sine squared of x plus cosine squared of x is equal to 1, cosecant of x is equal to 1 over sine of x. Things like those are identities. It means that they are completely equivalent parts on either side of our equal sign. So here are all the different identities that we've already established. For quotient identities, we have tangent of theta is equal to sine of theta over cosine theta. Cotangent of theta is equal to cosine of theta over sine of theta. Reciprocal identities are going to be cosecant of theta is equal to 1 over sine of theta. Secant of theta is equal to 1 over cosine of theta. Cotangent of theta is equal to 1 over tangent of theta. Pythagorean identities, these are sine squared of theta plus cosine squared of theta is equal to 1, tangent squared of theta plus 1 is equal to secant squared theta, and cotangent squared theta plus 1 is equal to cosecant of theta. Then lastly, we have our even odd identities. So this just meaning that sine, cosecant, tangent, cotangent, these are all odd functions, and our cosine and our secant functions are even functions. So using all these identities, we can move on. So this list contains what will be called as the basic trigonometric identities. So these identities that we've established over the last few sections, these are going to be known as the basic trigonometric identities. So these are ones definitely to be familiar with. You will need to know them in their original form, but also what they look like when they end up being manipulated. So knowing that tangent squared of theta can also be secant squared of theta minus 1, things like that. Just seeing how they can end up being manipulated and rewritten. All right, so objective 1, we want to use algebra to simplify trigonometric expressions. The ability to use algebra to manipulate trigonometric expressions is a key skill in establishing your identities. We can use 4 basic algebraic techniques to establish identities. So first being that you can rewrite an expression in terms of sine and cosine only. You can multiply the numerator and denominator of a ratio by a well-chosen 1. So that meaning that you can multiply anything by an equivalent of 1. Writing sums of trigonometric ratios as a single ratio. And then lastly, factoring. So let's go ahead and rewrite this. So example 1, we want to simplify 1 plus sine of x over sine of x plus cotangent of x minus cosine of x all over cosine of x. And we're going to rewrite this expression as a single ratio. That being said, by saying rewrite an expression as a single ratio, it just wants you to simplify down so that you have one thing in your numerator and one thing in your denominator. So you just want to simplify as much as possible until you get one item in the numerator, one item in the denominator. So that's what it means by a single ratio. So really, we're just simplifying this equation as much as possible. So by beginning to do this, we definitely want to combine both of these fractions. To combine our fractions, what we need to do is we need to multiply our first fraction by cosine of x over cosine of x, and multiply our second fraction by sine of x over sine of x. So we need to have the same denominator to combine them. 1 plus sine of x over sine of x. We multiply by cosine of x over cosine of x. This is our well-chosen 1. And we're adding this to cotangent of x minus cosine of x over cosine of x, And we're multiplying this by sine over x over sine over x. So now that we have this, we can go ahead and simplify. So we multiply our first fraction by cosine of x. This means we'll get cosine of x plus cosine of x times sine of x divided by cosine of x times sine of x. Then in our second fraction, when we multiply by sine of x, we get cotangent of x times sine of x minus cosine of x times sine of x. And this is all divided by cosine of x times sine of x. Now it's important to notice that cotangent of x is also cosine of x over sine of x. So what happens here is that our sine of x's get canceled out. Now what we have left over is cosine of x plus cosine of x times sine of x all over cosine of x times sine of x plus cosine of x minus cosine of x times sine of x divided by cosine of x times sine of x. So when we combine our two fractions here, we're going to end up adding our cosines of x, but then we're going to have cosine of x times sine of x minus cosine of x times sine of x. So those terms are going to end up canceling out. And what we're left with is a 2 cosine of x divided by cosine of x times sine of x, which then our cosines can cancel, and this leaves us with a final answer of 2 divided by sine of x. And this would be our single ratio. So that would be how we would simplify your expression into a single ratio. You want to simplify as much as possible, but mostly so that you get a fraction with one single term as the numerator and one single term as your denominator. So, all right, objective 2, we want to establish identities. So in establishing an identity, we start with one side, most often the more complicated side, and we use appropriate basic identities and/or algebraic manipulations to arrive to the expression on the other side. So some guidelines for establishing identities. It is almost always preferable to start with the side containing the more complicated expression. You want to rewrite sums or differences of quotients as a single quotient. Sometimes it's helpful to rewrite one side in terms of sine and cosine functions only. And always keep the goal in mind. As you manipulate one side of the expression, keep in mind the form of the expression on the other side. So for our example 2, we want to establish the identity cosecant of theta times tangent of theta is equal to secant of theta. So what to identify here is that secant of theta, this is our goal. We want to end up with secant of theta. But we end up having cosecant of theta times tangent of theta, so we're going to start with this side. So we want to rewrite things as much as possible. So let's go ahead and try and rewrite these in terms of sine and cosine. Cosecant of theta is just 1 over sine of theta, which we're multiplying by tangent, which is sine of theta over cosine of theta. When we multiply these terms together, it ends up giving us sine of theta over sine of theta times cosine of theta, which our sines of theta end up being canceled out. All this leaves us with is a 1 over cosine of theta, which is equal to secant of theta. So what we see here is that it worked. We see that we ended up getting our final answer of secant of theta, which is what we wanted from our goal. So this means that we are correct. Sorry, not that. There we go. So check mark, we've established the identity. So let's do a little bit of a harder one now. Example 3, we want to establish the identity sine squared of negative theta minus cosine squared of negative theta divided by sine of negative theta minus cosine of negative theta is equal to cosine of theta minus sine of theta. So one side is definitely more complicated than the other. So we're going to start here with this side, and we're ending here for our goal. So there's a lot to do with the side that we're going to start on. Let's start with using our even and odd properties. If we go ahead and we use our even and odd properties, we can try and just simplify these so at least we're not working with negative thetas. So if we want to start by using even odd properties, it's important to notice that something like sine squared of negative theta is the same as sine of negative theta squared. So this is going to help us use our even odd property. Then we can do the same thing for cosine. We get cosine of negative theta squared. Then in our denominator, we don't have squared terms, so we can just go ahead and use our even odd properties. We know that sine of negative theta is going to end up being negative sine of theta, while cosine of negative theta is going to be cosine of theta. So we have negative sine of theta minus cosine of theta. Then we can use our even and odd properties on the terms that we're squaring. So sine of negative theta we know is negative sine of theta, which we don't need the square brackets anymore. This is squared. And then we have minus just cosine of theta squared. And this is going to be all over negative sine of theta minus cosine of theta. When we square them, negative sine squared theta becomes positive. So we get sine squared theta minus cosine squared theta. This is all over negative sine of theta minus cosine of theta. So at this point, it's going to be really tempting to want to use the identity sine squared of theta plus cosine squared of theta is equal to 1. But the important thing to notice is that we do not have a plus symbol. We have a minus symbol, so we can't use it. But what we can use is factoring. We can factor sine squared of theta minus cosine squared of theta into, let's just put equal sign, sine of theta plus cosine of theta times sine of theta minus cosine of theta. And this is all over negative sine of theta minus cosine of theta, which we can actually turn into a negative 1 times sine of theta plus cosine of theta. And now we see that we have a sine of theta plus cosine of theta in our numerator and our denominator. So we can cancel those terms out. Then we're left with sine of theta minus cosine of theta over negative 1, which really just gives us negative sine of theta plus cosine of theta. Our goal was to have cosine of theta minus sine of theta, which is just rewriting negative sine of theta over plus cosine of theta. This is the same thing as cosine of theta minus sine of theta. And that was our goal. So we established our identity. So now if it ever would come in handy, we've established this identity that we can use in the future now. And example 4, we're going to establish another identity. We have sine of theta over 1 plus cosine of theta plus 1 plus cosine of theta divided by sine of theta is equal to 2 cosecant of theta. So 2 cosecant of theta, obviously the more simple sign, so this is going to be our goal. And our more complicated side is where we'll start. And when we start here, we're going to start here with multiplying by 1 to get same denominator. So we want to have the same denominator. So for our first fraction, sine of theta over 1 plus cosine of theta, we're going to multiply by sine of theta over sine of theta. Then for our second fraction, we have 1 plus cosine of theta over sine of theta. And to get the same denominator, we'll multiply by 1 plus cosine of theta, which we saw was our denominator in our first fraction. And we'll just go on to the next line here. I don't know if there's going to be enough room. There's going to be enough room. Let's do it. So when we multiply these, this is going to give us sine squared of theta over 1 plus cosine of theta times sine of theta. Say it's not going to fit, so we'll go to the next line. So we have sine squared of theta divided by 1 plus cosine theta of sine theta plus 1 plus cosine of theta squared over 1 plus cosine of theta sine theta. So they have the same denominator, so let's combine and simplify. So we have sine squared of theta plus, and now we're going to multiply out 1 plus cosine squared of theta. When we multiply these out, we'll end up getting a 1 plus, this is going to be 2 cosine theta plus cosine squared theta. All divided by 1 plus cosine of theta times sine of theta. So what we notice here is we have a sine squared of theta, we have a plus 1, and we have a cosine squared of theta. So we're going to rearrange our numerator to try and use that identity. So when we rewrite this here, we're going to say sine squared of theta plus cosine squared of theta, which we know is equal to 1 by our identity. And then on the outside, we'll have our plus 1 plus 2 cosine theta. Still all divided by 1 plus cosine theta times sine of theta. So replacing sine squared of theta plus cosine squared of theta, which we know is equal to 1, we'll replace this with 1 to get 1 plus 2 cosine theta divided by 1 plus cosine theta times sine of theta. 1 plus 1 we know is equal to 2, so really this is 2 plus 2 cosine of theta. Which, now if we factor out 2 in our numerator, we can say 2 times 1 plus cosine theta, which we're dividing by 1 plus cosine theta times sine of theta. And our 1 plus cosine thetas cancel. This then gives us 2 divided by sine of theta, which is a single ratio, but we know that our goal answer here is 2 cosecant of theta, so we're going to rewrite this as 2 times 1 over sine of theta, which gives us 2 cosecant theta. And that was our goal, which we've now established this identity as well. All right, so on to our last example, example 5. One last identity here. We want to establish the identity that tangent of V plus cotangent of V divided by secant of V times cosecant of V is all equal to 1. So obviously 1 is our goal. And this is the side that we'll start with. So we're going to start here. And we're going to start here by expanding with sine and cosine. Start here, expand with sine and cosine. So we're going to expand each one of our terms. When we do this, tangent of v is going to become sine of v divided by cosine of v, plus cotangent of v, which is cosine of v divided by sine of v, all divided by secant of v times cosecant of v. So this is 1 over cosine of v times 1 over sine of v. So we want to simplify this as much as possible. So our numerator is going to stay the same, sine v over cosine v plus cosine v over sine of v, all divided by 1 over cosine of v times sine of v. And now what we want to do is we really want to combine our terms in our numerator. So we're going to have to multiply by 1. And let's bring this down to the next line here. It'll be a little long. So in our numerator, for sine v over cosine v, we're going to multiply by sine v over sine v. So we have sine of v over cosine of v. And we're multiplying by the denominator over, multiplying by the value of the denominator of our other fraction over itself. So sine of v over sine of v. Plus, and then we're going to have cosine v over sine of v times cosine of v over cosine of v. And this is still all going to be over 1 over cosine of v sine of v. Lots of fractions going on here. So when we multiply these values together, we're going to get sine squared of v over cosine of v times sine of v plus cosine squared of v over cosine of v sine of v, all over 1 over cosine of v times sine of v. So we're getting there. Now we can combine our two fractions in our numerator. When we do this, we get sine squared of v plus cosine squared of v over cosine of v times sine of v, all over 1 over cosine of v sine of v. Which now we can realize that in the numerator of our numerator, we have sine squared of v plus cosine squared of v, which we know is equal to 1. So this simplifies down to 1 over cosine of v sine of v divided by 1 over cosine of v sine of v. So obviously we have the same thing in our numerator and our denominator. So this ends up being equal to 1. And there we have it. We have equaled, we have found our goal. So we've established our identity. So, all right, that wraps up our section 7.4. And so I will see you all again in section 7.5.